Hello, and welcome to this demonstration of the Oil Spill Analysis Tool, or OAT for short. This tool is designed to help the user in detecting, classifying and reporting possible oil spills. This is the main window. Initially it has two panels. At the bottom you'll find the product list, which contains a list of images to be analyzed. Let's start by opening an image. Select an image from the list and click Open. When the image is loaded, the panel window and main viewing area are shown. The panel window can be used for quick navigation in the image. A box represents the viewing area in relation to the full image. Moving the box around leaves a footprint in the panel window, allowing you to easily see which parts of the image has been visited. Before starting to look for possible oil spills, the image needs some contrast adjustment. This is done by simply dragging this slider. We can now use the panel to examine different areas of the image. Here are some suspicious dark areas in the image. First, we'll further adjust the contrast so that the areas stand out even more. These areas are candidates for classification, so I'll start by creating a new layer for the oil spills. Then I call up the toolbox and select the Magic Wand tool. By clicking and dragging I can stretch a rectangle to cover the area with the oil spill. Then, I select a pixel from the oil spill by clicking on it. Now the OAT extracts the contour of the area from the image. As you can see, too much was selected initially, so I'm going to adjust the threshold in order to get a better match. The approximation level can also be adjusted, depending on how closely the contour should follow the slick area. When I'm happy with the result, I click Finalize, which then commits the oil spill to the layer. This process is then repeated for all areas that can be possible oil spills. When I'm satisfied with my detections, I can start adding some properties to the possible oil spills. I'll call up the layer list by clicking this icon on the toolbar. This shows a list of layers for the active viewing area. The oil spill layer is already active, so I'll call up the layer details. This shows a list of the detected oil spills for the current oil spill layer. Now, I'll call up the Properties window in order to see information about individual oil spills. Initially, the properties consist of mandatory fields, some of which have to be filled out manually, and others that are automatically filled out. A list of available optional properties can be found at the bottom of this window. I'm adding orientation to the property list and specifying a value of 110 degrees. Next, I'll add confidence and choose the predefined value of medium. Some layers can automatically contribute to the oil spill properties. First, I'm adding country as a property. As you can see, the value is empty. Now, I'm going back to the layer list and preparing to add more layers. The layers will be added from the database. The database returns a list of layers that overlap geographically with the current image. In the list there is an entry for exclusive economic zones. I'm highlighting this and then click Load Selected Layer. The layer is now loaded from the database and added to the layer list. Going back to the oil spill properties, we can now see that the country property has been filled out with Norway. Other layer types can also be added. Oil rigs and subsurface installations such as pipelines can be significant in determining possible sources for oil spills. The same applies to marine vessels. The OAT can import such detections from other sources. An example can be an AIS service, or vessels detected from the SAR image itself. Wind can be important when determining the drift on an oil spill. The OAT can import wind from both meteorological models and detections from SAR images. Here, I'm loading wind vectors from the SAR image. Information from the wind layer is automatically contributed to the oil spill properties. As you can see, wind speed and direction is now filled out for the oil spill. When all relevant properties have been filled out for all the possible oil spills, the results are ready to be committed to the database. This is done by highlighting the oil spill layer in the layer list, and then selecting Commit Layer to Database. I'm marking the analysis as complete, and using the default layer name. Now the layer is committed to the database and the analysis is complete. Here's another example of layers contributing information to oil spill properties. First, I will identify a possible oil spill and mark it in a new oil spill layer. In the vicinity of the area, there is a ship. This is seen as a bright dot near the oil spill. This ship could possibly be the source of the oil spill. Now, I'm going to bring up the layer list and select an AIS layer that was already added to the image. Here we can see that the vessel in question has passed right through the area containing the oil spill. So, I'll call up the oil spill properties, and then add the possible source elements. Next, I'll click on Select Source. Then, I'll click on the trace that runs through the oil spill. The name and last known position of the vessel in question is then automatically filled out.